and will be applied. So it is good for readability to always apply these parentheses and check the order in which ands and ors and the combinations will be applied. So in any way, the result of these comparisons will be booleans. Question: what will be the result here? So not 2 not equal to 3 and true, or false and true. See this slide for a while. Even if you want to pause the video, see it and answer. The print will return true or false. Okay, with this question, I end this video. In this particular video, we just saw the comparisons on Jupyter Notebook. Just see how the comparisons return true or false. We combine the different trues and different Boolean values using ands and ors. And here is a question for you. Okay, I will see you in the next video with answer of this question. So I left you with a question in the last video. So that was the question, if you remember. So the question really was, what's the result here? So what's your answer? True or false? The result either will be true or false, because these are all comparisons and combination of Boolean values. So let's see step by step. First of all, let's see this 2 is not equal to 3. The result is 2 is not equal to 3. Yes, it is true. 2 is not equal to 3. That's true. So not true. Not true is false. So this is false. So this whole thing is false. Now false and true, that is false. So this whole thing here till here is false. Now we have or, and then we have false and true. Now false and true is false. So this whole thing is false, this whole thing is false, and or between. So false or false, it is false. So the result of this, so the answer to this question is false. Let me just convince you by typing this statement in Jupyter Notebook. So if you remember, we have print not 2 is not equal to 3, and then we were having, I guess, and false, and yeah, that was a statement, a different one, and true, sorry, that was and true. So this was and true, then we were having or, and then we were having these false and true. So the print ends here, and the result is, oh, I have some parenthesis mismatch. So not true and this, okay, I should have this one, I guess. This goes to there, and this goes to there, and I guess yes. So the result is false. The result is false. The purpose of this question was not just to, the purpose of this question is to appreciate actually the fact how we can combine different Boolean values to achieve the final Boolean value. And these kind of combinations will become very, very helpful further in control flow, when we will see the if conditions and decision making and stuff. So the answer to this question is false. Yeah. And I end this video here. In the next video, we are going to see some useful functions of Python. And after seeing some kind of useful, there are a lot of functions. We will see just a few of them, very useful of them. And after seeing those functions, then we will directly jump to control flow, basically the if conditions and stuff, where you will see these comparisons, these Boolean values in a much more applicable sense than earlier. So hope to see you in the next video. Okay, so let's have a very quick tour over some some useful functions in Python. Obviously there are a lot of functions in Python, but I will be covering just a few of them that I think with the passage of time we will be covering more and more, but let's start. A function or sometimes particularly a built-in function is basically a feature from the language that is supplied for the users to achieve particular task. For example, a round function. If you give round, for example, a round, let's say 4.6. This 4.6 is a floating point number, and rounding means make it as integer. What round does is it finds the nearest integer to 4.6. And the nearest integer in this case is 5, because 5 is more closer to 4.6 than 4. However, if you call round, for example, on 4.3, then the result will be 4, because 4 is more closer to 4.3 than 5. So that's one use of round. It rounds rounds a floating point number to the nearest integer. Another use of round is if you give another argument, that is called an argument to the function. For example, when you write print, let's say a, this a is called argument to a function print. Similarly, round is a function, 4.6 is an argument. Round is a function, 4.3 is an argument. We will see functions in details, and we will be writing our own functions as well. But for now, just bear with me that functions are these kind of features that are available. However, we will be writing our own functions later on. So this particular function accepts two arguments. So round has two different kind of implementation. One is when it accepts only one input argument, it returns the nearest integer to that. If it accepts a floating point number as well as another argument, like here we have 3, that means after point, after decimal, go to 3 places only and then round up, then round. For example, this 4.55, and then 8 will be rounded based on its next value. If the next value is larger than 5, then 8 will go to 9 and stop. If the next value is smaller than 5, then 8 will stay as 8, and the result will be 3 decimal places after this. Let's practice this round function just on a Jupyter notebook very quickly. Let's see. So here we are. So let's say print round, let's say 4.556, and in this case the result will be 4.5. And the reason is 4.5, when it's rounded up, it stays to 5. And the reason is this 4.556, it is more closer to 5 than 4. However, if you just print round 4.345, let's say, and the result will be 4. The reason is 4.345 is more closer to 4. However, if you call this round function with more than one argument, for example 4.556789, let's say, or with argument let's say 2, that means the result should be only 2 decimal places after the decimal point. So in this case the result is 4.56, and the reason is this 5 is rounded based on the next digit, and the next digit is larger than 5, hence it is rounded up. So 4.56. If, however, I call this function for 3, then what do you think? What will be the result? It will be 4.55, and the 6 will be rounded up based on this 7, and it will become 4.557. Yes. However, if, for example, there will be a value at the place of 7, if there is a value, let's say 3, then you call this function then 4.556, and then based on the next value 3, the 6 will stay as 6 rather than going to 9, and the result will be 4.556. Yeah, so that's the round function basically. Another function is div mode. Div mode function basically divides and returns quotient and remainder. So in the next video, we will be seeing this div mode in detail, how it actually works and how it is useful. So in this particular video, we saw round function. In the next video, we will see div mode, and there are a couple of more functions that we will see in the upcoming videos. So hope to see you in the next video. So in the last video, we saw round function that sometimes accepts one argument and sometimes accept two arguments and behave accordingly. In this particular video, we are going to see another function, div mode, and it accepts two arguments, two different arguments, maybe same or different arguments, and it returns two outputs, two numbers. It returns basically quotient and remainder. For example, in this particular case, the quotient is 5 and the remainder is 2, because if 27 is divided by 5, the result is 5, but then the remainder is 2. And the result is returned in a kind of an ordered pair, and these kind of collection in which we have two or more elements, we call these collection as tuple, that we will see in detail when we will see the data structures module of this course. But right now, just bear with me that it returns two numbers, two elements, and the two elements are ordered in an ordered pair, which is called a tuple. A tuple is not just an ordered pair. It can have 3, 4, 5, or 7, or maybe several elements. But right now, we will a tuple is just an ordered list, which we will see in detail. So let's see the working of this div mode function in Jupyter Notebook. Let's see. So let's say we have div mode. Let's say, for example, we have 34, and then we have, let's say, 10, or maybe let's say 9. So what do you think? What will be the quotient and what will be the remainder? So 9, 18, 27. So 3 is the quotient, and the remainder is 7. So 3 is quotient and 7 is the remainder. So and if you save the result, for example, if you save the result in a variable, let's say g, so if you see the g, the type of g, if you just type the type of, if you just print the type of g, it's a tuple, which we will see in details. And if you see the contents of g, the contents of g are 3 and 7. And if you want to access each element independently, then you can access the first element, because if there are multiple elements in a variable, normally that kind of variables are called collections, that we will see in detail later on. And these are the indexing, the positioning is start by 0 rather than 1. So G0 means the first element of G, which is 3 in this case, and the second element of G is 1 at 1, which is 7. So this is called the index or position of elements or data in this particular collection. We will see these indexing and all these kind of collections in detail in the data structures course, when we will see arrays and strings and different kind of structures. But and div mode sometimes is basically sometimes it is helpful. By the way, you can achieve div mode by another thing. For example, if you want to achieve div mode 34/9, you can do the same thing by, let's say, 34 divided by double divided by 9. That will give you a quotient, and the quotient is 3. And further, if you write 34 remainder 9, and that will give you the remainder that you need. So you can call that function div mode, or you can use these two. There are multiple ways of doing the same stuff. Okay, so yes, so I mean, sometimes it is useful when you're coding and knowing this kind of function that returns quotient and remainder. Okay, next function that is more useful is instance, and we will see this function in the next video. So hope to see you in the next video. Okay, this function is instance. It actually returns either true or false, and it just checks that particular given data value belongs to this type or not. For example, if you want to check whether 1 has type integer, so you can check that using this function. By the way, you know that 1 is of type integer, then you may think that why on earth one should be interested in checking the type of 1 if somebody know it is integer. Sometimes we have certain variables and certain data is stored in it, and we want to check the data inside it belongs to which kind of type. And in several cases, the value to this variable is not assigned by us. It may be read from some file, or maybe through input a user gives some number or something like so. So sometimes it becomes important to check the type of a particular variable. If we are expecting a particular type of the input and the input is different, then this function might be helpful somewhere. Either way, this is a function available in Python, and it checks whether the given value has a particular type or not. So is instance 1 int returns true? Is instance 1.0 integer? That returns false, maybe, because this is a floating point number. And you can check a particular value belongs to one of the several types or not. You can give several types in a tuple, and you can check whether it belongs to this this or not. So let's go to Jupyter Notebook and see actually how it works. So by the way, this is the same notebook that we have that we are populating. So hold on with me. At the end of the day, we'll be having one notebook complete. So is instance, let's say 3, is that instance of integer? The result is true in this particular case. If, for example, we check whether is instance 3.4 is that an integer? The answer is no, it is not an integer. If, for example, we check if this is not an integer, then maybe it is a float. The answer is yes. Or maybe we check that, for example, if that value is either float or integer. If it is one of these, then check that a particular value, in this particular case 3.4, whether it belongs to one of these types. We can increase these types, for example. So let's say we gave a complex number here and check is instance, let's say 2 plus 3j, that's a complex number, and let's say we ask whether it is an integer or float or not. The result is obviously false, and the reason is it is neither integer nor float. Or even if we give a string there, str, so it will still say no, it is not any of these. But maybe there is a complex data type. If we see that says yes, because it is complex. So sometimes this is instance becomes really useful. Next function is power. So power, you can compute power, by the way, using for example, if you want to compute x raised to the power y, you can use double star, and that computes exactly x raised to the power y. Or equivalently, you can call the function pow x comma y, and that will give you the same result as this one. But power sometimes take 3 arguments as well, and in that case it performs the power function in a different behavior. So for example, if you supply 3 arguments, what it does, it raise y to x raised to the power y, whatever the result is, then it takes the remainder by z and gives the result. So let's see the functioning of this power function in Jupyter Notebook. So let's say power, I want to compute 2 raised to the power 4. The result is 16. No problem. 2 raised to the power 4. I can compute the result 16 this way as well. But here is another way. How can we use this? 2 raised to the power 4. Whatever the result is, then I want to take the remainder by, let's say, I want to take the remainder by 7. 2 raised to the power 4 is 16. Then if we take the remainder by 7, the result will be 2. And that's the result 2. So that's how you can use this power function. I'm just introducing you some built-in functions that are available. There are so many functions that are available. I'm just getting you comfortable with these kind of functions so that in future, if you see another function that you have not seen here, you'll be able to use it and apply it. In this particular video, we saw this isInstance function and this power function. In the next video, we will see one more function that will allow you to take input from the user. So far, we are supplying values or assigning values to variables directly. What if on the fly we want to give the values and those values should be assigned to the variables? So in the next video, we will see the function. We will see a function that will allow you to give input from the keyboard. Hope to see you in the next video. So in this video, we are going to see a very important function called input. This function is this is beneficial for taking input from the keyboard from the user. The way to call this function is you type input and then you type a message that actually describes the expected entry. That, for example, enter something. If you want somebody to, or tell somebody to just enter, let's say, a number, you can write enter number, or any specification to help the user to enter whatever input the user want to enters properly. One thing is that no matter what the user will enter, the variable a will be having type string, str. So even if you enter a number, let's say 12 or 34 or whatever, that will be received as a string. And then there are ways to convert string to number if that really was a number. So whatever you receive using input function will be a string. And then there are ways to deal with that string if that was a number, how to convert that string to a number, and so on. So for example, let's see on the Jupyter Notebook how it works. So let's see, for example, x is equal to input, enter a number, let's say, and then if I press shift enter, a prompt will appear in front of you that will require you to enter a number. For example, if I enter, let's say 56, and then I press enter, not shift enter, enter, then x will receive 56. Now you might be thinking this 56 is an integer, so the type of x should be an integer, but this is not the case. The type of x will be a string. And the reason is whatever you enter is received as characters 5 and 6. Even if you have entered something else, that would have been received as a sequence of characters. So this is no longer a 5 as a digit 5, 6 as a digit 6. These are some characters, sequence of characters. Now, if you want to, there are ways to convert this x. For example, maybe you want, let's say, y or x as int x. So this means you have now converted this string to integer, and then whatever the result is, you have stored that result in x again. If you now see the type of x, the result is integer, and you can, for example, print x minus 34, and the result is 22 because x was 56. So this input function is, it is, and one way, by the way, if you are expecting an integer or a float value, for example, let's say you are expecting a float value, then it is good to write input, let's say enter a real number, maybe, or any message, and then at this particular time, at the time of input, then it is okay to convert that thing to a float, and it will become a float. Yeah, that's it. So now, for example, you enter 12.5. If you see the type of a now, type of a will be float. Okay, but there are problems. For example, if you are expecting float and somebody enters something that is not float, for example, a or let's say b equals float input enter a real number, let's say, and then you press shift enter and somebody just enters, let's say, ABC. So now this is not a float. ABC cannot be converted to a real number no matter what. So you will catch an error. There are ways to avoid these kind of errors and program breaks using exception handling, and there are other ways, but be careful. I mean, the user is not, the one who is going to enter the input, if that user is not restricted enough, then you can get errors. This is not the case that whatever you will enter, it will be converted to a float. If whatever you have entered is really convertible to a float, then it can be convertible to a float, not otherwise. And at the input time, there is no restriction. You cannot restrict the keyboard to enter what or what not, although there are ways to do that. So that's about the input function. So we have seen some of the functions. Let me just go through quickly. We have seen input, we have seen is instance, we have seen div mode, we have seen power function, we have seen the round function, and there are several others. Yes, so from now on we will be actually moving towards basically decision making based. Sometimes we will use these kind of functions. Mostly we will be using input function, but sometimes we'll be using maybe other functions like these functions, and sometimes we will be doing decision making based on these and stuff like so. One thing that I want to tell you is, if for example you know the function name, some function, let's say like power, you know that POW, power, is a function, but you do not know how to use that function. One way is to just type a question mark in front of it and then just press shift enter, and in front of you the documentation of the power will open up. So it will tell that this is power, that's how it should be called, and then some description will be in front of you, that equivalent to x raised to the power y with no arguments, with 2 arguments, or equivalent to x raised to the power y remainder with z with 3 arguments, and so on. If you want to see implementation of this function as well, we will see the functions later on, but if you want to see more about the help, you can type the double double question mark, and more things should be open up in front of you. So yeah, in this particular case, this power function does not have an implementation in Python, so the single question mark and double question mark are the same. One more way is to use the help function, help pow, and you will get a lot of information about the power, how for example help on built-in function pow in module built-in, so this is pow, this is equivalent to this, some key types and stuff like so. Or for example you want to know how can I use the input function, for example, so you can write help on input, and this is how this can be used. So sometimes it is okay if you know the name of some function and you know how to use it, you can just open up the documentation right here in Jupyter Notebook by either using a help function, or you can use just a question mark in front of the name and so on. So that's about the functions. In the next video we will be seeing the power of comparisons and the decision making, or sometimes called the control flow. So the real fun will begin from the next video, because we will be actually deciding which part of the code should run and which part should not run based on certain conditions. So hope to see you in the next video. Okay, we are in control flow, the most interesting part of any programming language. Well, assume that you have 2 numbers. You have taken 2 numbers from the user, A. You have taken that number from the user using input. I have not supplied the input message here. The message is optional. It's a description. If you supply that, that's okay. If you don't supply even that, that's okay. So A is some number the user will supply when the code will run. B is some number the user will supply when the code will run. Now, once you have A and B in front of you, obviously the user will supply that on the fly. You don't know what the value of A and B are, because when the program will run, only at that time the A will be populated and B will be populated. Your task is whatever the value of A is that you don't know, whatever the value of B is that you don't know, the user will supply those values. Your task is to print the value that is bigger than both. So for example, if A is bigger than B, then print A. If B is bigger than A, then print B. So whatever the bigger value is, print that value. Let's say that's your task. How can you do that? So the question is how? Does Python allow us to do that? For example, if A is bigger, then we should print A. If B is bigger, then we should print B. Remember, again and again, we are talking in terms of if A is bigger. So this is what, if A is larger than B, then this condition will be true. This is like the comparison. So this is true. But then we must have an if condition as well. If A is bigger, then do what? So if A is bigger than B, then do certain things. Otherwise, don't do those kind of things. So this if condition is really, really powerful and is available in all programming languages. In here, for example, let's see if A is an input, B is an input. Writing an if condition, that's if is a keyword. That's a comparison that we have done earlier as well. And then the syntax required a colon in front of that. So if this condition is true, if this comparison results true, remember the comparisons, they return Boolean values. If this comparison, whatever the result of this operation is, if that is true, then you go into this block. And whatever the statement inside is, do that. For example, print B is greater than A. Now my question is that done? Are we done with the task? The task was to print the bigger number. If B is greater than A, then B will be printed. Then, or we might have printed, for example, we might have printed, rather than writing this, we might have printed, let's say, just print B, because B is bigger. If B is not bigger than A, what we will do then? So yeah, if B is bigger than A, then B will be printed. Yes, because then you will be inside here. If B is not bigger than A, if this condition is false, we will do what then? So that's a question. So right now I'm just coding this in Jupyter Notebook, and then we will see how can we deal with that if B is not bigger than A kind of condition. So let's first see the blessings of if condition in Jupyter Notebook. Yeah, so let's say A is an integer. Let's say you're expecting an integer input, let's say, and then you write if, well, let's say B is again an integer input, maybe, and let's say if A is greater than B, then print A. That's it. That's your program. Remember this indentation. I have not written this print here. This is the indentation that defines the block of A. Let's say if I want to print A, then I want to print, let's say, I am still inside if condition. And so whatever that starts from this, whatever that starts from this alignment, if I write something here, let's say x is equal to 5, all that block is called the body of the if condition, if it starts from this alignment. If, however, I type a statement, but I type that statement in that kind of alignment, the alignment like this is no longer inside the if condition. So for example, here I type I am outside the if condition. So the purpose of writing these multiple lines is just the if condition does not require to contain only one line of code. It can contain a whole block of code, multiple lines of codes. So this is no longer inside the if condition. So now we will take input A, input B, whatever the numbers will be. If the value in A will be larger than B, then this will be printed and this will be printed. Once these two are printed, then this has to be printed regardless of the values of A and B, because this last print statement, it does not depend upon the values of A and B. The if condition has no impact on that. That is just a sequence of statements. The if condition, the statement inside the if are just these two. For example, if A is not bigger than B, then neither this will execute nor this will execute, but this will still execute because this has nothing to do with if condition. So let's run this code and see how it works. So let's say the value of A. See the power of descriptions. If we could have written a description, then the description could have appeared here. But let's say this is the value of A. Let's say 12. The value of B. Let's say 10. In this particular case, because the value of B is 10, the value of A is 12. 12 is bigger than B. If this condition is true, this statement becomes true. Whenever this condition becomes true, you are inside the if condition. Now this print executes and you get 12. This print executes and you get I am still inside the if condition, and this has to execute no matter what the values of A and B are. So now let me rerun this and give other values of A and B. Let's say the value of A is 10 and the value of B is, let's say, 45. Now this condition becomes false because 10 is greater than 45. This is not true, this is false. So whenever this condition is false, you never land inside the if condition and you go out from the if condition. So these are the statements that are inside the if condition. They cannot execute because you never visit them. They can only be executed if the if condition becomes true. So then once you're out the if condition, that's the statement that is going to be executed anyways. So yeah, so that's the flavor of if condition or decision making. And this is the comparison operator that returns a Boolean value. You may have different kind of comparisons here or combination of comparisons here, no problem, depending upon your logic. But the question is, are we done? We are going to print only the bigger number. We have printed the one that is, if A is bigger, we have printed that. What if B is bigger? We have not solved the task yet. This is the task, we have not solved the task yet. So how to do it? Okay, so yeah. It looks like complicated. How to print only that number that is bigger? So if B is bigger than A, then we will print B. Maybe we should apply another if condition. If B is bigger than A, then print B. If A is bigger than B, then print A. Maybe. Yeah. Why not? So. So for example, let's go to Jupyter Notebook and write the following. Let me write a whole new program here. A equals int input. Okay, let's do not have a message. Int input, and then if A is bigger than B, then print A. Okay. However, if B is bigger than A, then print B. I guess we are done. If this condition becomes true, then we are here. And we know if this condition becomes true, then this condition cannot become true because it cannot happen that A is bigger than B as well as B is bigger than A. This cannot happen. So whatever the bigger number will be, that will be executed. Further, you can see I have this if condition and this if condition. They are aligned in a way that this if condition is not the second if condition is not inside the body of the first if condition. We will see such cases when this is required, but right now I guess we are done. If A is bigger than B, then print A. If B is bigger than A, then print B. And only one of these if conditions will become true, because A is bigger than B, B is bigger than A. These two statements cannot be true at the same time. So let's see. So A is 10, B is 45. So the answer is 45. Wow, because 45 is bigger. So let's run it again. So A is, let's say, 22, B is, let's say, 4. And the result is 22 because 22 is bigger. I guess we are done with the task. We have used this if condition twice to achieve the task, to print the number that is bigger, and both the numbers we took both the numbers from the keyboard. Yeah, I end this video here, and in the next video I will tell you more features of this if condition, particularly the else statement. What we have done recently with another if could be achieved through an else statement that is more powerful, more readable. So in the next video I will talk about else statement, which is a part of if. So hope to see you in the next video. Okay, in the last video we saw if condition, and we actually had an example in which we wanted to just print the greater number. So we input a number A, we input a number B, and if B is greater than A, we printed B is greater than A. Then we applied another if condition to check if A is greater than B, then print A. The else clause, or the else part of if, is as the name suggests, if this condition is true, if this condition is true, this particular condition is true, then go there. If this is not true, which means else, if this is true, then go there, else go there. So if this is true, then you land here. If this is false, then you land in else part for sure. And this else is, if B is greater than A, if that condition is true, then you print this thing. Otherwise, A might be greater than B, or A might be equal to B. Either way, you land in else part. So this if and else, they both have this alignment, but then the block of else started from this particular alignment. Maybe you have more statements here. The alignment of this if block started from here, and you may have more statements here. So let's go to Jupyter Notebook and see the else running. So let's say A equals int input, and B is int input, and we say okay, if A is greater than B, then print A, else print B, else print B. Now B will be printed even if it is equal to A, or if it is greater than A. Either way, B will be printed. So let's just see, let's just run this and see what happens. So shift enter, so input a number. So A is, let's say, 10, and B is, let's say, 12. So what do you think? When I will press enter, what will be printed? B or A? B, yeah, B is printed. That's what B is printed. Now if I run this again and A is 10 and B is 10, still the 10 will be printed. So let's modify. Let's just say that print if part. So that means we landed in if part. Otherwise, we landed in else part. So just to be more elaborative, let's say, so 10 and 10, and we landed in else part. And the reason is if A is greater than B, so 10 is greater than B, 10 is greater than 10, false. So you go to else, and the else block, the whole block just executed. So that's what else is. It's really very nice to have an else there. If this is false, whatever that condition is, if that is false, then you land in else. So yeah, that's else part, simply. Now okay, so we have this if else structure. We can have one more power with this if. What if we want if B is greater than A, then you print B. Else if A is equal to B, then you print they are equal. And if this is false and this condition is false, if both these conditions are false, then you go to else part. So basically if, else if, else if, else if, else. So you can have really deep structure. For example, in this particular example, if B is larger than A, then you land in this part. Else if, this if is just short form of else. Else means B is not greater than A. Else, you can have another check. Else if A is equal to B, then do what? If we can have one more check, we can have one more check, we can have several checks, and then else. Else will only execute if all the if conditions or else if parts on top, their conditions, they are false, and only then else will be execute. So let's see these else if running on Jupyter Notebook. Okay, so let's say A is int. So rather than taking inputs, let's say A is 1, B is, let's say, 5. Let's say we have taken these inputs, A is 1, B is 5. If A is equal to B, then do what? Print equal if, which means else if. Now because this is if, you have to write a condition here which will be either true or false. If A is larger than B, then do what? Then print, let's say, A, and else, let's say, you print B. Okay, so that's it. And this statement, print, is not in if condition, not in if. This is outside complete. This is complete if condition with all its else and else if parts, and this is no longer inside. So let's run this. What do you think? What will be the result? If A is 1, B is 5, then else part is going to be run, because A is not equal to B. A is equal to B, that's false. A is larger than B, that is also false. So you will land in else part, and B will be printed, and then a statement will be printed which is not in if. So yeah, so B is printed and not in if. If B is 10, then what will happen? A equals to B, that is false, so you will not land here. Else if A is larger than B, true, you will land here. Because you land here, else will not execute. So A will be printed and then not in if. If A is 10 and B is also 10, let's say, then you have equal. Yeah, so that's else if. Okay, so that's about if, else if, or short form is LF, else structure. In the next video, we will be talking more about this if, else structure in a bit more detail, and we will also be giving you a short form of this kind of else if structure. So hope to see you in the next video. Okay, one way of writing this if else kind of structure, there is a short form as well, which is written down here in this green color, for example. This is kind of a same code that we saw in the last video, but that's the short form. Let's say a equals 9 and b equals 10, then print a if a is larger than b, else print this particular thing if a is equal to b, else print that. This is exactly the same kind of structure. For example, print a if a is larger than b. So you just read that if a is larger than b, then print a. Else if a is equal to b, then print equal. Else print that. So that is kind of a short form of writing this if else kind of structure. But I will recommend to use, the structure in this particular horizontal form rather than writing that in this particular way, because this kind of structure, that horizontal kind of structure, is much more readable, much more manageable, and this structure might be confusing sometime for some kind of readers. And also if this structure goes on and on and on, which we will see in an example today, writing very deep and lengthy structures in short form is not very feasible. So but this feature is there if you like to write if else kind of structure in this way. This is available in Python. Okay, let's get a good grip on this if else structure on Jupyter Notebook. Let's move on to Jupyter Notebook to see an example, just an example. So let's say the example is user will input a number. Let's say int input, let's say, and enter marks. Let's say enter marks for a particular subject. Let's say user will enter some marks, and our goal is if the marks are larger than 85, then we will print A grade. If the marks are larger than 80 but smaller, so if the marks are larger or equal to 85, then we will print A grade. Else if marks are larger or equal to 80 but smaller than 85, then we will print A minus grade. And if marks are larger or equal to 75 but smaller than 80, we will print for example B grade, for example B grade, and so on. And let's print this whole nested structure. That let's make this else if kind of structure a little lengthy. Let's get comfortable with it. So if A is larger than or equal to 85, to enhance readability, it is good to include a space after the variable and space, but don't actually write the space inside that, because larger and equal to, they combine without space is an operator. So if A is larger than 85, then print, let's say, A grade. L if A is larger or equal to 80 and A is smaller than 85. So let me write this in a more readable form. Else if A is smaller than 85 and A is larger or equal to 80, then we should do what? It is sometimes good to include these kind of parentheses. Sometimes it is good just to make these things more readable, that this is one block, this is one boolean, this is one boolean, this is one decision, this is one decision. Although not writing the parentheses is also okay, but writing the parentheses make code a little more readable. So for example, if a is smaller than 85 and a is larger than 80, if that is true, so remember and is true only when the left side is true and right side both are true, then this whole condition becomes true. And I promised you that I will show you the power of comparisons and actually combining the Boolean variables using ands and ors and stuff like so. So here you're seeing the one. In that case, let's say print, let's say a minus grade, and elif if a is smaller than, if a is smaller than 80 and a is bigger or equal to 75. If that's the case, then what should we do? Let me omit the parentheses just to show that whether writing parentheses or not writing parentheses is perfectly okay. I just recommend to write parentheses so the code becomes much more readable than otherwise. Okay, then we have print, let's say B grade, and let's say one more elif if a is smaller than 75 and a is larger or equal to, let's say 70, then print B minus grade, let's say, and